Today we're going to look at inverse operations. Inverse means the opposite. So if we had an addition calculation, we would do subtraction. If we had a subtraction calculation, we would do addition. If we had a multiplication equation, we would do division. And if we had a division equation, we would do multiplication. First, let's have a look at an addition calculation. 34 add 12. So first I need to find the total of 34 add 12, which is 46. To do the inverse, I need to do a subtraction calculation. And I take the total, and that's the number I start with, and then I subtract one of these two numbers here. So I'm going to subtract 34. And 46 subtract 34 equals 12. Can you see the numbers in the addition calculation and the numbers in the subtraction calculation are the same, they're just in a different order. Now there is another subtraction calculation that you could do. I'm going to take the total again, 46, but this time I'm going to subtract 12. And 46 subtract 12 equals 34. So once again, can you see in all three calculations, I have used the same three numbers. Now let's have a look at 56 add 31. So first I need to find the total of 56 add 31, which equals 87. So to do the inverse, I need to subtract because the opposite of addition is subtraction. I start with my total, which is 87, and I choose one of these two numbers to subtract. First, I'm going to subtract 31, and I need to find the difference. 87 subtract 31 equals 56, has a difference of 56. So can you see again that both calculations are using the same numbers? The other subtraction equation that we could do is 87 at the start again because that is my total, and this time I'm going to subtract 56. And the difference of 87 and 56 is 31. So can you see all three calculations are using the same numbers, but they are in different orders because we've done the inverse. Next, let's have a look at a subtraction equation. I have got 75 subtract 34, and I need to find the difference. 75 subtract 34 equals 41. Now, when you do the inverse of a subtraction equation, you do have to do addition, but you want to get the answer, the total of 75. So both times you're going to get the answer 75 because that is the biggest number in your subtraction equation. Now, there are two ways that you can do this. I always start with the difference number and add the other number that was in the calculation. Or you can start with the number that was in the calculation and add the difference. And both times you get 75 because you're adding these two numbers together to get the biggest number. Let's have a go at another subtraction equation. So I've got 61 subtract 30. I'm going to find the difference first. 61 subtract 30 equals 31. Now remember, the inverse of subtraction is addition, and you're trying to get the total of the first number in your subtraction equation. So both times you need to get a total of 61. And you're just going to use the numbers that are already in the top equation. So I'm going to start with the difference and add the other value. 31 add 30 equals 61. And then I'm going to start with the value in the equation and I'm going to add the difference. 30 add 31 equals 61. Can you see that in the addition equations, the two numbers that you are adding together swap around and you get the same total? That's because just like in multiplication, you have commutativity in addition to. That means it doesn't matter what order those two numbers are in, you will get the same answer. Now let's have a look at a multiplication equation. Now we have done this before when we used arrays to help us find the different calculations that we could see. So let's do this one. 8 multiplied by 6 has a product of 48. The inverse of multiplication is division, and you have to start with your product first. So 48 divided by, I'm going to divide by 8 first, and the answer is 6. 48 divided by 8 has a quotient of 6. For the next equation, I'm going to start with the product again because it is the biggest number, and I'm going to divide by 6. Now you don't know your 6's, but remember you can only use the numbers in that first equation. So 48 divided by 6 must equal 8. Let's have a go at another multiplication equation. 4 multiplied by 9. 4 multiplied by 9 has a product of 36. To do the inverse, we have to divide, and you have to start with the product first. So 36 divided by 4, I'm going to do first. And 36 divided by 4 has a quotient of 9. For the next equation, we're still dividing and I have to start with that product again, and I'm going to divide by 9 this time. We haven't done our 9s in yellow class, but once again, have a look at that top equation and see which number has not been used. 36 divided by 9 must have a quotient of 4. Let's try a division equation. 56 divided by 8. 56 divided by 8 has a quotient of 7. To do the inverse, we're going to multiply because the opposite of division is multiplication. When we do the inverse for division, we must get a product of 56. So both times what we multiply together must equal 56. I'm going to start with the quotient and I'm going to multiply it by the divisor. 7 multiplied by 8 equals 56. For the next equation, I'm going to start with the divisor and I'm going to multiply it by the quotient. 8 multiplied by 7 equals 56. Can you see, just like when we had to add to do the opposite of subtraction, we're using the same two numbers in this part of the equation and the answer stays the same. That's because when we multiply, we have commutativity. It doesn't matter what order these two numbers are in, you will get the same product. Finally, let's have a go at 32 divided by 4. 32 divided by 4 has a quotient of 8. Now when I do the inverse, I'm going to multiply, and both times I need to get a product of 32. That first number in my division equation. First, I'm going to start with the quotient and I'm going to multiply it by the divisor. 8 multiplied by 4 has a product of 32. Then I'm going to start with the divisor and multiply it by the quotient. 4 multiplied by 8 equals 32. So remember, each time you do the inverse, the numbers in the equation should stay the same as the numbers in that top equation. The order of them is what is switched around. I really hope this video has helped you understand what inverse operations are. Remember, they are the opposite. Have a go and see how you do. See you soon!